Hello students, today we are going to know about acrylic fiber, its history, definition, the manufacturing process, various properties of acrylic fiber, and also the reasons why consumers prefer acrylic fiber, and also the various brands that are available in the market. The fiber is named from the Latin word acryl, which means bitter, irritating or pungent. These adjectives hardly describe acrylic, but they do describe a compound called as acrylic acid. Acrylonitrile, which is chemically related to acrylic acid, is the compound from which the acrylic fibers are polymerized to form polyacrylonitrile. Acrylic fiber was first discovered by Dr. W.H. Caruthers' team in 1893 when he was working for an American DuPont company. Even though they knew about the possibility of making a fiber from acrylonitrile, the commercial production did not take up 1940s. The reason for the delay is because the polymer could not be melted without degradation and the solvents were not known to the scientists to dissolve the polymer. Once they knew about the solvents, they discovered solvents in late 1930s and early 1940s. After the discovery of solvents, the commercial production was taken up intensively. This commercial production started in the year 1950 and the fiber was trademarked under the name Orlon. The manufacture of acrylic steadily increased in 1950s and 1960s and it peaked in 1980s. So let us know about the definition of acrylic fiber now. TFPIA, that is Textile Fiber Product Identification Act, defines acrylic as a manufactured fiber in which the fiber forming substance is any long chain synthetic polymer composed of at least 85% by weight of acrylonitrile units. Acrylic fiber is processed in 4 basic steps: synthesis of raw material, that is acrylonitrile, formation of polyacrylonitrile, fiber formation process, stretching or orientation of the spun fiber. How is this raw material synthesized? Basically from ethylene or acetylene, which are petroleum derivatives. When hypochlorous acid is added to these petroleum derivatives, chlorhydrin is formed. The chlorhydrin is reacted with sodium hydroxide to form ethylene oxide. To this ethylene oxide, when hydrochloric acid is added, cyanoalcohol is produced. When you dehydrate the cyanoalcohol, we get acrylonitrile. Now let us see how acrylonitrile is transformed into polyacrylonitrile. This is done through addition polymerization process. Acrylonitrile can be polymerized through bulk polymerization, emulsion polymerization, suspension polymerization, and solution polymerization. Bulk polymerization is done by using azo or peroxy compounds. The polymer reaction is exothermic in the sense that it produces heat. A thick paste is formed. This spinning solution is not suitable for direct spinning. Now, suspension polymerization is done by dispersing the monomer in water. In this process, it is easy to remove heat, unlike in bulk polymerization, but this process also does not produce spinning solution which could be used directly for spinning. The third process, which is emulsion polymerization, is also carried out by dispersing the monomer in water. This as well is not suitable for direct spinning. Now the last one, which is solution polymerization, is the most ideal or suitable process of forming polyacrylonitrile. The acrylonitrile is dissolved in solvents like dimethyl formamide or dimethyl acetamide. The solution that is obtained through solution polymerization can be used directly for spinning. Students, let us now know about the manufacturing process and chemical composition of acrylic fiber. This acrylonitrile through addition polymerization is used for the spinning solution. This acrylonitrile is made to dissolve in solvents like dimethyl formamide or dimethyl acetamide, and it is made into a spinning solution. The dope or spinning solution is filtered to remove impurities, and it is also vacuum treated to remove air bubbles. Now when we remove this air bubbles, it is possible to produce a smooth continuous filament fiber. The dope is made to pass through a spinneret. Spinneret is going to have a lot of holes, so the spinning solution is forced through the spinneret into a hot chamber. That's the reason why this is called as dry spinning. The filaments are coming out of the spinneret into a hot chamber. They solidify upon contact with air, and then the solvent is evaporated. The evaporated solvent is again recovered. The reason being the solvents are very expensive. The filaments that come out of the spinneret are cold drawn to increase fiber orientation to about 3 to 10 times depending upon its end use. Now when it is intended for filament form, the cold drawn filaments are given a slight twist and taken on to the bobbins and wound onto the bobbins. Now when they are intended for staple fibers, then they are given a slight crimp and then they are cut into staple lengths and they are spun on cotton system. Now let us look at the chemical composition of acrylic fiber. We just established the fact that acrylic is manufactured from acrylonitrile. It is a polymer and it has about 1900 monomer units. DuPont created this first acrylic fiber back in 1941 and it was trademarked under the name of Orlon. So acrylic is also called as Acrylon. The acrylonitrile polymer is one of the longest manufactured fiber polymers with a degree of polymerization of 1000 units. So the backbone of this polymer is covalently bonded atoms, that is the hydrocarbon linkages. This polyacrylonitrile polymer is rod-like. It is flexible, not rigid, because it has good dipole interactions between nitrile groups of the same chain or with the adjacent chain. The proportion of crystalline area and the amorphous area in acrylic has not been established. Let us look at its structure. When you view acrylic fiber in a microscope, in a longitudinal view, one can see striations. These striations are parallel to the fiber axis. Now when you look at its cross-sectional shape, one can see the dumbbell shape. One can also see pitted appearance or dotted appearance in the cross-sectional shape because a delustrant called as titanium dioxide is added to the spinning solution in order to reduce the brightness of the fiber. Now let us look at density of the fiber. Acrylic has a very low density of 1.16 grams per centimeter. Because of this low density, it facilitates or it gives excellent covering factor to all the fabrics. Now let us look at the strength of acrylic fiber. Strength is measured in terms of tenacity. So the tenacity of acrylic fibers ranges from 2.2 to 2.6. However, these fibers are likely to lose their strength in wet condition to a considerable extent. In spite of this, it is possible to make fabrics that the consumer desires. Now let us look at elasticity. Elongation at break of acrylic fiber is considered to be medium. The fibers show high elastic recovery at 90 to 95% extensions, and the recovery from higher extensions is going to decrease considerably. Now let us look at resiliency of the fiber. Acrylic fibers are supposed to have good resilience. It is because of this factor that acrylic fabrics resist wrinkling, or even if undesirable wrinkles or creases form, it is easy to remove these wrinkles just by hanging the garment. So bulkier acrylic fabrics are more resistant and they are more lofty. Let us look at abrasion resistance of acrylic. Acrylic is supposed to have moderate abrasion resistance. Now coming to moisture regain, acrylic fiber is a hydrophobic fiber, which means it does not like water, just like polyester. So acrylic fiber has a regain of 1 to 2.5%. Fabrics made out of filament fibers have lesser absorbency when compared to fabrics that are made out of spun fibers. Because of this lower absorbency, acrylic fabrics do not attract any stains, or even if they do attract stains, they are easier to remove. Now let us look at dimensional stability of acrylic fiber. The fabrics show good dimensional stability in normal use. Looking at drapability, acrylic fabrics are supposed to have good drapability or good drape characteristics. Now let us look at thermal properties of acrylic fiber. Coming to heat conductivity, acrylic fibers, like other synthetics, do not conduct heat well. So we just came to know that acrylic fiber shows dumbbell shape in cross-sectional view. Because of this dumbbell shape, it is possible to retain air or air pockets within the fabric. That's the reason why it provides warmth to the wearer. And more bulkier fabrics provide more warmth. So that's the reason why acrylic fabrics are suitable for winter season. Now let us look at the burning properties of acrylic fiber. These fibers shrink away from flame, but when they are in the flame, they take up the flame readily, and when they are removed from the flame, they burn faster, and subsequently they form a black bead which is very hard and brittle. The fiber starts to melt at 232 degrees centigrade to 255 degrees centigrade. So that's the reason why the safest ironing temperature that is supposed to be suitable for acrylic is lesser than 160 degrees centigrade. Now let us look at chemical properties of acrylic. The effect of alkalis. Acrylic is supposed to have fair to good resistance to weak alkalis and strong alkalis at room temperature. Now effect of acids. Acrylics are highly resistant to acids, be it organic or mineral acids. Now effect of bleaches. Acrylics can be safely bleached with any bleach or any household bleach. Now let's come to other properties of acrylic fiber, like the effect of sunlight. Acrylic has excellent sunlight resistance. Now let us talk about the effect of moths and mildew on acrylic. Acrylic is supposed to have excellent resistance to the growth of mildew and all types of moths and insects. Now effect of perspiration. Perspiration does not have any effect on acrylic fabrics. And looking at electrical conductivity, acrylic fibers have poor conductivity of electricity. That's the reason why static electricity develops on the fabric when we are wearing it on the body. Now let us look at various finishes that could be given to acrylic. One such finish is heat setting finish. This gives permanent shape to the fabrics. Another finish that can be given to combat the problem of static buildup is anti-static finish. So this finish avoids the buildup of static electricity on the surface of the fabric. A water repellency finish can also be given to acrylic. That is a special purpose finish. Now napping is also a finish that can be given to acrylics because it helps to enhance the warmth of the acrylic fabrics. Now let us see the blends that are available in acrylic fiber. Acrylics can be blended with any fiber, be it cotton, rayon, other fibers like wool, synthetic fibers like nylon, polyester. Various varieties of blends are available in the market, and these blended yarns are used in various knitted and woven fabric constructions. Students, we just saw about different blends of acrylic that are available in the market. Now let us know about the different trade names through which acrylic is marketed. It is available under various trade names, namely Acrylon, Orlon, Crestlon, Zephron. The Indian trade names through which acrylic is generally marketed in India is Indacryl, Supracryl, Jacacryl, Acrylon, Indlon and Concrylon. These are the different trade names through which acrylic is available in India. Students, let us know about the reasons why consumers prefer acrylic. The first and foremost being it is good for winter clothing. So because it provides warmth, and it is also possible to produce lightweight or bulky fabrics. It is economical. Acrylic fibers are a cheaper alternative to wool, which is very expensive. They are used in apparel and also for other kinds of warmer clothing. Acrylics also possess easy care characteristics, and spun acrylic blends are highly preferred in the knitting industry. Let us know about the care of acrylic fabrics. It is very simple to take care of acrylic fabrics. One can launder acrylic fabrics at home in all the home laundry equipment, but consumers should keep in mind that excessive heat should not be given to acrylic fabrics. So whenever the fabrics are transferred to a drying chamber, the temperature of the dryer is to be set at either medium or at low levels, because acrylic fibers are sensitive to heat. Fragile and delicate items made out of acrylic fibers are supposed to be laundered with hand with gentle care, because you do not want to give excessive rubbing to it and damage the fabric. Consumers must also read care labels that are attached to the product and adhere to the care procedures and suggestions that are given on the care labels. Now let us know about the uses of acrylic fiber. It is mainly used in apparel industry, in sportswear, in children's ski clothes, sports suits. Acrylic could also be used in making sweaters, scarves, tracksuits, and in making linings, boots and gloves. They are used to make hats and the hand knitting yarn, socks, awnings, boat covers are also other areas where acrylic is used. The fiber is also used as a pan precursor for carbon fiber production. It is also used in making blankets, blankets. And other upholstery materials because of its excellent resilience property. Acrylic is light in weight, it is soft, it is warm, and it has a wool-like feel. So it can be made to mimic other fibers such as cotton when it is spun on short stable equipment. Acrylic is also used in clothing as a less expensive alternative to cashmere because wool and acrylic have similar properties.